And welcome back. We are going to go ahead and continue our review. Today we're going to focus on classes. Now, if you remember, classes have a lot of different important things, and it's really what kind of gives Java its bread and butter as an object-oriented programming language. And so when we start diving into classes, remember that they are used to create what we call objects within the Java programming language. And those objects are what are ultimately going to give us the most amount of bang for our buck when we actually start making different things. Now, classes can be placed in the same or separate documents as the main method. Generally, though, when we look at the main method, it's going to be in its own class and therefore its own file. Helping classes are going to be in separate files. So we saw this before when we looked at things like employee and date and stuff like that, when we have those different objects where they're going to kind of behave in different ways. Now, classes, of course, have several properties for their methods and variables. One of the most important things we have to remember are those things that are public, which are accessible by the whole program, and things that are private, which are accessible only by the class to which they belong. There is other levels of access, but these two are probably going to be the most important ones that we kind of work with. Now, first things first, let's jump right in and we talk about how variables get used with classes. If you recall, all variables should be marked as private unless otherwise noted. Most of the time when we have a instance variable for a class, it is going to be private. There are occasions when we do want to make a variable public, but generally we want that security to be tighter, so we make our variables private and then instead use methods to access those values. Now, these instance variables are variables belonging to that class, and keeping them to that class is part of the reason why we want to make it private. We don't want another class necessarily coming in and modifying those values directly. Now, there's also local variables, which are typically variables that are going to be within inside of a method itself. And if it is a variable to that method, remember you can't use it in another method because, again, it's local to that method. Java does not have global variables, so there's not a way necessary for a variable to be used across an entire program, unlike in some programming languages. But we do have methods, and methods are where we really start adding our punch here to our programming. With methods, remember that we have to mark them as public. Unless they are belonging to typically a helping method, then we might make them private because we don't want the programmer to have direct access to them. And as such, methods are broken down typically into constructors, which are simply methods that define variables and properties of the default object. So these are things that are going to say, hey, I have a class called dog, and I need to make a dog object. Well, it's going to look to the constructor to see how and what does that dog object have. You have mutators, which are methods that change the variables or properties of an object. You have accessors, which are simply going to access or return the values of a method. And you have what we call helping methods. These are usually our private methods, and they aren't accessible by invocation. You can't say like, dog, new dog or anything like that in dot and call a helping method because, again, they're private. They're not accessible. But if we look a closer look at our mutator methods, one of the most common things we're going to see is that these are also a lot of times known as set methods. All right, these are the methods that we're going to use to set a value. All right, and that value is a lot of times controlled by what we're passing in as a parameter value. So here's two quick examples that both are effectively doing the same thing. We have public static void set name, string new name, name equals robo. Or we have public static void set name, string name, this name dot name equals name. You'll notice that with the second one, we're using the this keyword in order to identify which name we want because we probably have a name instance variable in the class. We also, of course, have our accessor methods. With accessor methods, remember, these are methods that we're probably going to use the key of get. All right, mutators set, accessors get. And because they're getting something, that means that they're going to return a value. And this is how we get to those values of those variables that we had marked private at the top of our class. For example, we have a variable called name. We can use a method probably called getName in order to return that value. And that keeps that variable safe away from outside interference. Now, the value is defined typically within our method header. So, for example, if I say public int get number, that's probably going to mean I need to get a numeric value. So return number picked in this case. Now, we all, of course, have constructors. As I already mentioned, constructors are very, very important within our program. If we have a class, let's say we call it my class, it may have multiple constructors that may use variables belonging to the class object. And that's the thing, we don't necessarily have like one constructor, no constructors, but multiple constructors a lot of times are defined typically for the different combination of variables within that object. So here's an example of what we call a no-R constructor. And no-R constructors are another way to think about it as the default constructor. So when you're not passing in any parameters. So my class, and you can see we have no parameters here in our parentheses, so that's empty. And I'm just saying number equals 0 and line equals null. In this case, there's probably instance variables called number and line that belong to the class. And of course, we're just initializing them to these values. Now this example shows a parameterized constructor. So here I'm again creating my class in first number, string first line. We have one for number and line correspondingly. So number instead gets set to first number and line gets set to first line. So whatever the programmer is inputting here for these two values is what's going to be determining what goes into my class. Now if we actually want to use a class object, it's very, very important that we be able to do so because we want to be able to, for example, let's say we have a dog class and I have another program called, let's say, dog walker, and I want to be able to create different dog objects that I can then use in that dog walker class. Well, I also not just want the objects, I'm going to want their methods too, so I can use the appropriate means, like maybe I need to get the name of the dogs. So let's just say, let's use that custom class called my class again, and we have a main class called main. So we're going to create an instance of the object within the class. We'd have to type, for example, my class object name is equal to new my class. Remember, the new is the keyword here that is going to be very important to tell Java, I want a new instance of my class. Then if we want to invoke a method of class, we'd have to type something like object name dot my method. Object name, of course, whatever the name of that object was. If we had, for example, using that dog class that I talked about, let's say it's dog, my dog equals new my dog, or new dog, then my dog would then be my dog dot walk, for example, or my dog dot get name. Conversely, there might be times you want to just call the method in the class directly. In that case, you'll have something like my class dot random math method like here. And in these cases, a lot of times what you're going to have here, instead of having to create a object, these are a lot of times going to be defined with a static invocation, and that's what we have here. All right, so let's actually go over to Clips and take a look at some code that we can actually look at and see how this class is being implemented. So here I have a review class object, and I have a private static int called input. So this means this is a input here that is going to be stored. You notice it's private because it's a variable that belongs to this class. I've also created a private scanner object because I'm going to need it for various different components up here, but I don't want this modified directly. Then we have a user input method, and if you notice, it will then ask them to enter an integer. It's going to get the input. It's calling the output method, which is very important. Note that other methods can call other methods here. So output is being called within user input, and then it says input squared. If you look at input squared, all it's doing is it's taking input and set equal to input times input, and then it's just outputting again. All right. Now, if you notice here, input squared is a private method. So this would be more of a helping method here because, again, it's not accessible by the rest of the program. Get input is a accessor method because we see that get keyword there. We have private static void output, which is simply just outputting something. We have user input. And all these are very, very cool to use. But let's say we want to actually create a instance of this review class. So all I'm going to do is I'm going to come over here to my program. I'm going to go ahead and create a new class. And I'm just going to call this review class demo. Let's go ahead and create that main method. And all I need to do to create this object is I'm going to call it review class. Let's just call this demo object equals new review class, open close parentheses with a semicolon. Now notice I didn't have to pass anything in here because if you look in here, I don't have any constructors defined. And you'll sometimes have that with classes. You won't necessarily define a constructor, which is fine because then Java can infer with the no R constructor what you want that to do. Then let's just go ahead and say demo object. And let's invoke our class objects that we can do. Here's our method. So we have an equals, there's get class, get input. We have toString. Some of these are built right in, but we want to maybe use the user input method because, of course, that one is what's going to actually call everything. And so if I go ahead and run this program with user input, it's going to first start off, enter my favorite integer, which if you look, that's what it asked me to do right here, enter the favorite integer. So let's just say we go ahead and type the number 10. You'll see then it gives me the value of the input is 10, the value of input is 100, because it just simply says output and then output. So it's simply just returning those values there. Now we of course could come in here and add more things. For example, we could have maybe a mesh that says like in our input squared, saying like the input is being squared, so that way we know how this is being changed. But that would be something that we as the programmer could come in and do. Now, of course, there are things that we're going to look at in this class that we can look at, for example, that would make review class better. We can override it and maybe even derive a class of this. And that's something, a term we're going to hear later on as we get further into this course.